carbohydrate that is of most importance to living organisms, like ourselves, is called glucose. This simple sugar is found naturally in most fruits, but most of the carbohydrates that we eat are actually converted into glucose in our digestive system. This includes table sugar, which the technical term for table sugar is sucrose, and it also includes the starchy carbohydrates that we find in breads and potatoes. The glucose, once we've eaten it and digested it, begins to circulate through our blood system. And it's circulating at about a concentration of roughly around 0.1%. Circulating glucose is something that we call blood sugar, and it has one of three fates. We're going to talk about those three fates in today's lesson. In this video lesson, we take a closer look at glucose, a carbohydrate that provides energy for our body's cells. By the end of the video, we should be able to describe the three fates of the carbohydrate glucose. The first fate for the sugar that's in our blood system is that it becomes fuel for cellular activity. So once it arrives at and enters into a cell, glucose can then be used as an energy source. Through a series of chemical reactions, which we're actually going to learn about later on in this course, the relatively high energy bonds in those glucose molecules are converted into lower energy bonds of other molecules. The change from higher energy to lower energy bonds actually releases energy in that process. And organisms use that released energy in order to fuel their cellular activity, including the muscle contractions that enable you to move and the nerve activities that enable you to think. The second fate for our sugar, or glucose, is that it can be stored temporarily as glycogen. So if there's more glucose circulating around in our bloodstream than what we need in order to meet our body's current energy needs, that excess glucose can be temporarily stored in various tissues, mainly our muscles and our liver. The stored glucose molecules actually link together to form these big, large webs of molecules, and we call that glycogen, one of your vocabulary words. When you need energy later, that glycogen can then easily be broken back down to release glucose molecules that go right back into your bloodstream. So glycogen is really the primary form of short-term energy storage in animals and humans. Our third fate for glucose is that it can be converted to fat. So finally, glucose circulating in your bloodstream can actually be converted into fat. And fat is really just a form of long-term energy storage. Carbo loading is a method by which athletes can, for a short time, double or triple the usual amount of glycogen that's stored in their muscles and liver. This increases the store of fuel available to them during extended exertion. And it delays the onset of fatigue when they're performing in an endurance event, such as a triathlon or a marathon or some other kind of event, which requires them to exert a lot of energy over a long period of time. Now, carbo loading is usually done in what we call a depletion phase and a loading phase. What this means is that like 6 or 7 days before a competition, the athlete will actually deplete the glycogen that's in their muscles through a super low carbohydrate intake, so they don't eat a lot of carbs, and they do exhaustive exercise. And then about 2 days before the competition, the athlete will begin eating a super high carbohydrate diet, and they'll reduce the amount of exercise that they're doing in order to achieve a higher blood glucose than is necessary. And this creates a lot of excess glucose stored in their muscles and their liver as glycogen. Glycogen also plays a role in the initial rapid weight loss that people experience when they begin dieting. Think about it. If you reduce your caloric intake such that your body is really burning up more calories than you're consuming, then your body has to use that stored energy. So the first and most accessible molecules that can be broken down for energy in the absence of sufficient sugar in your bloodstream are those glycogen molecules in your muscles and liver. So large amounts of water are actually bound to the glycogen. And so as that glycogen gets removed from your tissue, that water also gets removed. And this loss of water leads to that initial dramatic weight loss that occurs before your body resorts to using stored fat. And the rate of weight loss actually then begins to slow considerably after that initial loss of water weight.